Hello everyone. Today we are going to discuss cycloaddition reactions. This lecture is focused on introduction and Woodward-Hoffmann selection rules for different cycloaddition reactions. Cycloaddition reactions are the most useful pericyclic reactions in organic synthesis. These are the reactions of two pi systems to form ring compounds by breaking up two pi bonds and making of two sigma bonds in a concerted process. The reverse of cycloaddition reactions are known as retrocycloaddition reactions. Typical examples are the conversion of two molecules of ethylene into cyclobutane and reaction of 1,3-butadiene with ethylene to produce cyclohexene. During the cycloaddition reactions of two ethylene molecules, two pi bonds are consumed. In replacement, two sigma bonds in the product cyclobutane are formed. Similarly, during the cycloaddition reaction of 1,3-butadiene and ethylene, two pi bonds of the reactants, one from each, are consumed to form two sigma bonds in the product. Based on the number of pi electrons of the reacting species involved during the reaction, cycloaddition reactions have been classified as 2 plus 2, 4 plus 2, 6 plus 2, 4 plus 4, 8 plus 2, 6 plus 4, etc. Now we will learn two terminologies which will be used for the derivation of Woodward-Hoffmann selection rules for cycloaddition reactions. For the cycloaddition reaction to occur, HOMO of one reactant interacts with the LUMO of other. Positive terminal lobe of one can interact with the positive terminal lobe of other, and negative terminal lobe of one can interact with the negative terminal lobe of other. If the structure of HOMO and LUMO of the two reactants is such that bonding interactions occur between the lobes on the same face of one reactant and the lobes on the same face of the other, the interaction is called suprafacial interaction. If the structure of HOMO and LUMO of the two reactants is such that bonding interaction occurs between the lobes on the same face of one reactant and lobes on the opposite faces of the other, the interaction is called antarafacial interaction. Now let us derive the Woodward-Hoffmann selection rule for 2 plus 2 cycloaddition reaction. In the previous lecture, that is electrocyclic part 1, we have already learned how to make Haeckel molecular orbital diagrams for ethylene and different conjugated pi systems. In ethylene, there are two pi molecular orbitals, Psi1 and Psi2. Under thermal condition, Psi1 is fully occupied by two pi electrons and Psi2 is fully vacant. So, Psi1 acts as HOMO while Psi2 as LUMO. During cycloaddition, HOMO of one ethylene molecule combines with the LUMO of other. Since HOMO and LUMO have two different symmetries, so the allowed bonding interaction will be antarafacial, which is not possible in small ring systems like cyclobutane. So, 2 plus 2 cycloaddition is thermally not allowed. Under photochemical condition, one of the two pi electrons from Psi1 jumps to Psi2, making Psi2 as HOMO. Symmetry of HOMO of excited molecule and LUMO of ground state molecule are the same. So, the allowed bonding interaction will be suprafacial. That will allow the formation of cyclobutane ring. So, 2 plus 2 cycloaddition is photochemically allowed. Woodward-Hoffmann rules for 4 plus 2 cycloaddition reactions under thermal condition. In 4 plus 2 cycloaddition, under thermal condition, Psi2 and Psi3 of butadiene are HOMO and LUMO respectively. In ethylene, Cy1 is HOMO and Cy2 is LUMO. If we look at the structure of HOMO and LUMO of 1,3-butadiene and ethylene, we will find that HOMO of one and LUMO of other have the same symmetry. Thus, HOMO of 1,3-butadiene can combine with the LUMO of ethylene, or HOMO of ethylene can combine with the LUMO of 1,3-butadiene in a suprafacial fashion. But in general, interaction between HOMO of 1,3-butadiene and LUMO of ethylene is energetically more favorable because of a smaller energy gap between these two molecular orbitals. So, 4+2 cycloaddition is thermally allowed. Under photochemical condition, one of the two electrons from Cy2 of 1,3-butadiene jumps to. Under photochemical condition, one of the two pi electrons from Cy2 of 1,3-butadiene jumps to Cy3, making Cy3 as HOMO and Cy4 as LUMO. In ethylene, Cy1 is HOMO while Cy2 is LUMO. The HOMO of butadiene and LUMO of ethylene have different symmetry. So, the allowed interaction will be interfacial. The molecule resulting from the interfacial interaction will be 2 strand to be formed. So, 4+2 cycloaddition is photochemically not allowed. Based on the previous discussion, we can summarize Woodward-Hoffmann rule for cycloaddition reaction in a tabulated form. If the number of pi electrons of both the reactants taking part in the reaction is 4n, that is 4, 8, 12, etc., under thermal condition, allowed mode of bond formation will be interfacial, while under photochemical condition, it will be superficial. If the sum of number of pi electrons of both the reactants taking part in the reaction is 4n plus 2, that is 6, 10, 14, etc., under thermal condition, allowed mode of bond formation will be superficial, while under photochemical condition, it would be interfacial. Even though interfacial bond formation is symmetry allowed in certain cases, as shown in the table, it can occur only with the rings that have 7 or more ring atoms. Please subscribe my channel and check out upcoming videos to enhance your chemistry knowledge.